Hi everybody. So it took a quarantine for me to get on one of these videos, but here I am. I want to talk to you about rationalizing the denominator. This is something that is pretty new, but hopefully it won't be too difficult because it's based on something that you have already learned as we've been dealing with these radicals. So stay with me and write down any questions you might have and then shoot me an email or call in during my Zoom office hours tomorrow. But our assignment for Wednesday, April 1st, not a fool's day, we are going to be rationalizing the denominator. So first thing we need to know, there are no radicals allowed in a denominator. Just like we're not allowed to have a negative in a denominator, we're not allowed to leave an answer with a negative exponent. There are just rules for how we can and cannot write our answers, our results in math, and we cannot leave a radical in a denominator. It's just the way it is. So what does rationalizing the denominator mean? Well, we should know what rational means. It's one of our number categories, and we know that a rational number is a fraction. It can be a whole number, an integer, it can be positive, it can be negative. We have all these different types of numbers that are rational. What is not rational, though, is a radical that is not a perfect square. So the square root of 2, for example, that is not a rational number because it is a decimal that doesn't repeat or terminate. It goes on forever. So that makes it irrational. So when you see rationalize the denominator, all they're saying is don't let there be any radicals in the denominator. If there is a radical in the denominator that can be executed, like it's a perfect square, go ahead and execute it. If you can't execute it, you have to get rid of it. And that's what we're going to do now. So here's our first example. If I have the square root of 3 over 9, I know some of you may be looking at that and saying, well, I could just reduce that right away, right? I could make this a 1, make this a 3, but then you're going to have the square root of 3 in the denominator, and you'd have to get rid of it anyway. So if you see that this is already a perfect square, this example is up here so that if you can execute the radical on the denominator, go ahead and do it. That gets rid of the radical for you, okay? So again, if the radical in the denominator, like in our first example here, is already a perfect square, just go ahead and execute it. Then the radical's gone and you're all set, okay? So here, the radical 3 is in the numerator, the radical 9 is in the denominator, so I split the radical. I executed the radical on the denominator and I leave the numerator the way it is, and I'm all finished, okay? So that one kind of rationalized itself because I was able to execute the square root. However, this next example, we have the square root of 3 over x. Well, I cannot take the square root of x. I have no idea what that is. So when I split my radical and I end up with radical 3 over radical x, I can't leave it there. That is a radical in the denominator, and I can't leave it there. So what I'm going to need to do is I'm going to need to get rid of that somehow. And the only way that I can get rid of a radical is to either square it or multiply it by itself, which is the same thing, right? Squaring something and multiplying it by itself, it's the same way to get, it's the same thing. However, I can't square this value because it's an expression. If I square that value, if I just put parentheses around the whole thing and wrote squared, I would be changing the value, and I can't do that. Now, if there's an equal sign, which there will be in another section or so, if there's an equal sign, then I can absolutely square both sides in order to get rid of that radical. But there is no equal sign here, gentlemen, so I cannot do that, okay? I cannot do it. So what I'm going to do instead is, just like we do when we're trying to get a common denominator, I'm going to go ahead and I'm going to multiply it by 1. But I get to decide what that 1 looks like. So I need the 1 to look like something that will get rid of radical x. And again, we know that we could square it and get rid of it. Radical x squared is just x, okay? But since I can't square it, I will multiply it by itself kind of the same thing. But I'm going to multiply the top by radical x also. And hopefully you guys are going to say out loud as you're sitting there watching this video, radical x over radical x is what? It's 1, right? We are always allowed to multiply a value by 1. We just decide what that 1 looks like. And in this case, 1 is radical x over radical x. So that when I multiply radical x times radical x, I get x. Remember, again, times itself, you could either think of it as the square root of x squared, which is x, or you can say I'm basically squaring this, and the radical and the square undo each other. They're equal but opposite, so it takes away the radical, okay? Up here, radical 3 times radical x is radical 3x. I can't simplify that. I definitely know I cannot reduce those x's because one's in a radical and one isn't. So that is my final answer. I am done. Okay? So that is rationalizing the denominator. Let's do another example. This one looks a lot more difficult, but the good news is once you realize how to do it, it's not difficult at all because you're going to do the same thing every time. So take a look at this one. This was a monomial, right? One term. What do we call this? A binomial. So radical 2 plus 1 is the denominator. That's a binomial, and unfortunately there's a radical in it, which means I can't leave it there. I have to rationalize it. I need the radical to go away completely. If I try to do what I did up here with the monomial and just multiply it by itself, it's not going to go away because I would have radical 2 times radical 2, which would be 2, which is fine. But then I would end up with 2 radical 2 in the middle, and I would still have a radical. So what I have to do, hopefully you remember this from when we did our double distributive section. And in that section, it was called our special cases. And when we multiplied a binomial times itself, when they were the exact same. So let's take a look over here. Remember when we did x plus 3 times x minus 3, okay? Over here for a minute. Remember when we did this, we multiplied a binomial times itself, but one was plus and one was minus. What happened was the first distributive we did, we got a value, x squared, no problem. But then we would go x times negative 3 was negative 3x. Then we would have 3 times x was positive 3x. And then we would have 3 times negative 3 was minus 9. Remember, these two middle values canceled each other out every single time. And that's going to happen every single time when you multiply a binomial times itself with the opposite sign. So let's go back to our denominator with a radical. If I have a binomial, 2 terms, see I put the parentheses around it, I have radical 2 plus 1. If I need to get rid of that radical 2, the only way to do it is to multiply this binomial times itself with the opposite operation. So look what happens. Radical 2 times radical 2 is 2. Radical 2 times negative 1 is negative radical 2, or negative 1 radical 2, same thing. 1 times radical 2 is positive radical 2, or positive 1 radical 2. And 1 times negative 1 is negative 1. Notice this note here. The radical must drop. That's why we're doing this. That's what rationalizing the denominator means. Get rid of the radical in the denominator. So what happens here is this negative radical 2 and this positive radical 2 take each other out. The numerator is 3 times radical 2 minus 1. Now this is just a hint, and it might not come in too handy yet, but very soon it's going to be very handy. So don't distribute right away. Just trust me on this. We're going to have the opportunity to reduce when these problems get a little bit more complicated. And if you distribute too soon, you won't be able to reduce, which should sound very familiar because we did this before when we were still in the classroom, where we left it all factored so that we could reduce. Hopefully you're remembering this, right? Okay, so I've got 3 times radical 2 minus 1. Then I have, again, this negative radical 2, this positive radical 2 is 0. So I have 2 minus 1 is just 1. I see I'm not going to need to reduce at all because I have a 1 in the denominator. So I'm going to go ahead and distribute 3 radical 2 minus, oops, that is a mistake there. 3 radical 2 I got from doing that, minus, and then 3 times 1 is 3, and then I just didn't need to put that 1 denominator. All right, now again, the nice thing about videos is you can now stop this, go back, okay, and listen to that again if you need to, all right? If it made sense the first time, let's do one more example, okay, and apply what we hopefully are starting to understand. So here's my original problem, okay, the black marker is 4 over radical x minus 1. That's my original problem, and the words simply say, or directions, simplify. Well, simplify does mean that you have to rationalize the denominator. Just like, again, we never leave a negative in a denominator, we never leave a negative exponent, we never leave a radical in the denominator. It's just the way math works. So, I've got to get rid of this radical x. Now, if I tried to multiply this by just radical x, it wouldn't go away, okay? Yes, radical x times radical x would give me an x, but radical x times the 1 would leave a radical x in there. So if you have a monomial, like up here, you can multiply by just a monomial. But if you have a binomial, which we all know, that's what this is, right? We put those parentheses in to help us see it as a binomial. If I have a binomial, the only way to get rid of it is to multiply it by itself, same binomial, but opposite operation. Okay, opposite operation. So this was a minus, I've got to use a plus. But the radical x minus 1, radical x plus 1, the values stay the same. So now let's go ahead and write our new numerator. 4 times, because this has parentheses up here too. So 4 times radical x plus 1. Again, try to fight the urge to distribute that right away. Just trust me, it'll pay off later. And let's go ahead and double distribute this to make sure our radical goes away. So I have radical x times radical x. That's just x. Then I have radical x times 1 is positive 1 radical x, or positive radical x. Negative 1 times radical x is negative radical x. And negative 1 times positive 1 is negative 1. Again, just like it did above, these two drop. Okay, they drop each other. They take each other out. So now there's no radical left in the denominator. So I have x minus 1 left as my denominator. I'm not going to be able to distribute, or excuse me, I'm not going to be able to reduce. So I'm going to go ahead and distribute my numerator. 4 times radical x is 4 radical x, and 4 times 1 is 4. So that's all I can do. I started with this. I end with that. It looks complicated, but all I really did was multiplied by the denominator with the opposite operation. Okay? Now, as we go through these next few assignments, whether it's on my math lab or on quizzes, or I have you write out a worksheet, whatever the case may be, I want to encourage you to, before you go online to try to just get it done, look in your book, okay? This section is still what we were doing before. So you could find examples of this in section, I'm double checking right now. Should be 9.4, but I'm going to double check. Yep. All right, so in section 9.4 and in the integrated review, you will find problems. Obviously, they're division, okay? So you're looking for dividing radicals, which is section 9.4. And there are going to be directions that specifically say rationalize the denominator. So look for those in the book. Practice them first, okay? I'm looking and I see, let's see, page 589. You could practice this starting at problem 49 through problem, 83, okay? And all those odds are going to be in the back of the book. So I would encourage you to practice them first in the book, then go to the online assessment, well, the online work, okay, the homework, and try to do it there. If you're trying to learn something at the same time you're trying to fill in this online timed thing, it may not be the best indicator for you as to how well you do or don't know the material, okay? Quite frankly, I'm seeing some pretty low scores on some of the online work, whether it's quizzes or my math lab. I'm seeing some low scores, which worries me because when we do start taking assessments and tests, graded quizzes and tests on these, which we are going to have to do, then you're not going to do well. And that's going to be a bummer. So I want you to please go in your book, try some first, then do the online assessment, which is posted on Portals, and email me or call in during my Zoom office hours, 11:45 to 12:15. It's the exact same Zoom link, Zoom number, and meeting number that I always use. Just call in. You'll be in the waiting room queue, and I'll pull you in one at a time. If we have a lot of the same kind of questions, we can just do a group review very quickly and get it all done. So good luck, guys. Please keep me posted and let me know if you're having any trouble. Take care. Talk to you later. Bye.